warahmatullahi wabarakatuh. Welcome everyone to our first lecture in ITDR2103. This is Alia, and inshallah we'll be introducing the congruence topic in three main parts. Each part will be in separate video. So congruence 1, we will discuss about the introduction to congruence, definition and rule. In congruence 2, there will be a discussion on modular classes, modular explanation, addition and multiplication of congruous classes. And finally, we will see how we can solve linear congruence, inverses, Chinese remainder theorem. Okay, let's make it easy and simple. All right, so before we start about the congruence, you can refer to page 341 in our textbook and section also 6.3. Okay, so in case I have two integers and positive integer, then I can say that A is congruent to B mod M if A and B have the same remainder when M divides both A and B. And we usually use the following notification, which is the 3-line equals, to represent the congruence. So what I mean by this, when I said A is congruent with B modulo M, I means that when M divides both A and B, I should get the same remainder. Otherwise, we can say that A is not congruent to B mod M, and it's written as you can see here. All right, now let's check one example to find whether A is congruent to B mod M. When A equal 19, B equal 24, and M equal 5, and we should give a reason. Now in this example, we will go step by step. Okay, later on we can do all these steps in our mind with head calculations. All right, okay, so let's start to find whether A is congruent to B mod M. So in order to do this, we need to find the remainders and they should be equal. Then I can say A is congruent to B mod M. How we can find the remainder? We can find the remainder in three main steps. So we will take first A equal 19 and we will find the remainder. How we do so? First of all, let's divide 19 by 5. And if we do so, we will find that we get a fraction point. So we will take the number before fraction point and multiply by M. So the result is 15. Now to find the remainder, we just need to minus 15 from 19. And we got the remainder as 4. Here is the remainder. So let's convert those steps to the following equation. So I got here that 19 is equals to 3 times 5 plus 4. Let's do the same steps to find what is the remainder when I divide B, which is 24, by 5. So first we divide 24 by 5, then I'm getting the result as 4.8. Then we take the number before fraction point, which is 4, multiply by 5, we got the result as 20. Then we need just to subtract the number we are looking for and by 20, and then we got the remainder as 4. So converting the following step to our equation, we got that 24 is equals to 4 times 5 plus 4. And if you notice here, yes, we got the same remainder. Then 19 is congruent to 24 mod 5. All right, okay. We have another condition. If it's met by A and B and M, then we can say that they are congruent to each other. And this condition is, we said A is congruent to B mod M if and only if M divides A minus B. What do we mean by M divides A minus B? We means that when I divide A minus B by M, then I get C multiplied by M plus 0, no reminder, which also means that A minus B is multiple of M. Okay, now let's check with our example there. We got that A equals 19 and B equals 24 and M is 5. So in order to find that is M divides A minus B, then we should do 19 is congruent to 24 mod 5. So we need to subtract A from B. So I'm getting the following number in here. So we got 19 minus 24 is congruent to 0 mod 5. Okay, now 19 minus 24 equals to 25 is congruent to 0 mod 5. And we can just take the minus outside. So we got as minus 1 times 5 is congruent to 0 mod 5. And if you notice here, 5 divides 5. So when I divide 5 by 5, I get the result as 1, no fraction point, which means there is no remainder. Okay, how if we do in the opposite way? So 24 is congruent to 19 mod 5. Will we be getting the same results? Let's check. So in order to do A minus B, I need to take 19 there. So 24 minus 19 is congruent to 0 mod 5. So 24 minus 19 equals to 5 congruent to 0 mod 5. And yes, 5 divides 5. So here 19 is congruent to 24 mod 5 and 24 congruent to 19 mod 5. And this one take us to one of the properties of the modular, which is if A is congruent to B mod M, then B is congruent to A mod M. And this is one of the equivalent relation properties. So we need to keep this in our mind because it will help us on solving the next problems. All right. Now let's check the congruence here. A and B module M is true or not, and we should give reasons. So in case we have A equals 17, B equal 2, and M equal 5, we will be again using the same steps just to make sure that you got it. So here we got that 17 divided by 5 equals 2. 17 divided by 5 equals to 3.4. Then we need to multiply the number before fraction point by 5, and we got as 15. Then yes, subtract 17 from 15 and we got the result as 2. So 2 is the remainder here. So we need to convert the following steps to one equation, and we got that 17 is equals to 3 times 5 plus 2. Now let's find the second number, which is 2. 2 divided by 5 equals to 0. 0.4. Take the number before fraction point, which is 0, multiply by 5. We got the result as 0. Now 2 minus 0 equals to 2. And here we got the remainder. Converting the following step to one equation, we got that 2 is equals to 0 times 5 plus 2. And here we got that the reminders are equal. Then yes, 17 is congruent to 2 module 5. Okay, let's check again one more example in the same steps. So here we got that 11 and 3 congruent to m, which is 5. So 11 divided by 5, we got the result as 2.2. Take the number before fraction point, multiply by 5, we got the result as 10. Now to find the remainder, just subtract 11 from 10 and the result is 1. So this is the remainder. Again, convert the following step to one equation and we got that 11 is equal to 2 times 5 plus 1. All right. Let's check with the answer, the second number, 3. So 3 divided by 5 equals to 0.6. Again, take the number before fraction point, which is 0, multiply by 5, and we got the result as a 0. Then 3 minus 0 equals to 3. All right. Now 3 is equals to 0 times 5 plus 3. And if you notice here, the reminders aren't equal, then yes, 11 is not congruent to 3 module 5. One more thing, if you notice in here, if one of the numbers are less than m, then we got the same remainder in here. So here we have 2 mod 5 equals 2. When I divide 2 by 5, I get the remainder as 2. And in here, we got 3 mod 5 equals again 3. So keep this also specification in your mind that if I divide a smaller number than m, then I'm getting the same number as a remainder. Now let's check the same values but trying to meet the second condition where m can divide a minus b. All right, now here we have, yes, here we have 17 congruent to 2 mod 5. To find whether a minus b divides by m, then we need to take 2 outside. So here we have 2 congruents, 17 minus 2 congruents to 0 mod 5. And 17 minus 2 equals to 15 congruents to 0 mod 5. And yes, 15 can be divided by 5 with the remainder 0. Then yeah, 17 is congruent to 2 mod 5. Now in here, in case we want to check the same condition, then we should give 11 congruent to 3 mod 5, then take 3 outside, then 11 minus 3 congruent to 0 mod 5, And then 11 minus 3 equals to 8. And unfortunately, 8 is not congruent to 0 mod 5 because 5 does not divide 8. Therefore, the relation is not there. Now let's check this question. We need to find the remainder when 38 is divided by 7. And again, we can use the same tiny steps to find the remainder. So to do so, just first of all, we need to divide 38 by 7. Then we got 5.42. Okay, then just take the number before fraction point, multiply by 7, we got as 35. Then subtract 38 from 35, and we got that the remainder is equal to 3. So here the remainder is 3. Now, as we did earlier, just convert the following steps to one equation. We get use it. So 38 is equals to 5 times 7. 5 times 7 plus 3. Okay, and also the following equation means that 38 is congruent to 3 mod 7. So you see, from one question we got steps, then the remainder, then the equation, and finally the relation. Okay, now here we need to find the possible values of B for the congruence, A congruent to B mod M, if A equal to 3 and M equal to 5. And you just need to concentrate in here that we can find possible values, not one value. So in order to solve this problem, we will just recall the second condition where M can divide A minus B. So here we got that A is congruent to B mod M. Okay, we have 3 as A, B is unknown, and M is 5. Now, in order to solve the problem, and from our modular properties, we can just switch the places in here. So we got that B is congruent to 3 mod 5. Okay, now from here we can notice that 5 divides A minus B, which means now the value in here is represented by A and the value in here represented by B. So 5 divides B minus 3, which means that B minus 3 is a multiple of 5. What do we mean by a multiple of 5? We mean that there is no remainder. The value here can be divided by 5 with no remainder. Now, in order to put B in a side and all the none in the second side, then we just take 3 here. So we got as b is equals k times 5 plus 3. And again, k is any integer number. It can be minus, plus, and 0. And again, it can be minus or plus or 0. Okay? And we got k because b minus 3 is a multiple of 5. And here we reach the end of our first session, where we identify that A is congruent to B modulo M if I divided A by M and I divided B by M, then I got the same remainder. And we can get the remainder from the following steps. Or A minus B is a multiple of M, which means A minus B can be divided by M with no remainder. Otherwise, we just said that A is not congruent to B. Thank you guys for attending this session, and let's go to our second session. See you then.